You are experiencing a unique two-host AI conversation powered by Google's Notebook LM for deeper, more dynamic book analysis.
Welcome back, everyone.
Today we're pulling something off the shelf that looks, well, deceptively simple.
It's definitely one of those topics where the surface is calm, but the depths are chaotic.
I mean, it might just change how you see the chair you're sitting on, the water you drink, and even the words coming out of our mouths right now.
Absolutely.
We're tackling element from the great ideas Syntopicon.
And right away, people are thinking chemistry class.
Right, the periodic table on the wall. But this essay by Mortimer Adler, it traces a 2,500-year-old detective story about what reality is actually made of.
And that's the key. It is not just about chemistry. Adler takes us on a journey from ancient Greece to modern nuclear physics, but he also pulls in logic, grammar, and even music.
So the mission of this discussion, it's really about exploring that human impulse to find the simple thing inside the complex thing.
That's the driving force. Is there a bottom? Is there a smallest thing?
Or does the rabbit hole go down forever?
Exactly. Adler starts with a definition that seems straightforward, but then immediately complicates it.
He defines an element as the smallest component into which something can be analyzed.
And from which it can be reconstituted.
Okay, so it's the Lego brick. I can build a castle, and I can take the castle apart back into individual bricks.
In a sense. But Adler is very specific about context. He uses the example of language, which I think is much more helpful than jumping straight to physics.
The letter example.
Yes.
Right. He says letters are the elements of words.
Consider the letter A. It's an element of the word apple. You can analyze the word down to that letter.
Sure.
But, and here's where people get tripped up, you can physically split that letter A if it's written on a page.
Of course. I can take a magnifying glass and see the ink. I can scrape the ink off, divide it into particles.
But the moment you do that, does it function as a letter anymore?
No. It's just a pile of black dust.
Exactly. You've left the domain of grammar and you've entered the domain of physics or chemistry.
So an element is irreducible, but only within its specific domain.
That's the crucial distinction. If you chop up a letter, you haven't found a smaller letter. You've destroyed the letter entirely.
That's a really helpful way to frame it. So in music, a tone is the element. If you break the tone down into sound waves.
So you're not doing music theory anymore, you're doing acoustics, you've changed the system you're operating in.
Got it. Okay, Adler also draws a line between three things people often confuse: element, principle, and cause.
Right, this gets a little technical, but it's important.
Walk us through that, because to me, a cause and a principle, they sound pretty similar.
They're close,
Yeah.
but an element is a part of the whole, it's inside the thing. A principle is a source from which consequences flow, like a starting point in an argument.
And a cause.
A cause is an origin that produces an effect. The key is that the same thing can be all three. Think about the matter in your body. It's an element, the stuff you're made of. It's a principle, the source of your physical properties. And it's a material cause. It all depends on which pair of glasses you're wearing.
Okay, so let's jump into the time machine. This whole debate starts way back with the pre-Socratics.
It was the first great scientific question. From what do all things come?
Thales said water, Heraclitus said fire. But where this really gets systematic, and this surprised me in the essay, is with medicine.
It sounds strange to us now, but you have to put yourself in their sandals.
They didn't have microscopes.
They had the human body. That was the only complex system they could observe closely.
The body was their laboratory.
And what's the most obvious thing about a body? It changes. You get a fever, you're hot. You catch a chill, you're cold. You get dehydrated, you're dry.
So they identified these four ruling qualities.
Yeah.
Hot, cold, dry, and moist.
The famous four humors. But here's the bridge to physics people miss. They realized health was a balance. And if the body is made of these balancing qualities, maybe the universe is too.
That is a huge leap, though, from I have a fever to the universe is made of fire and earth.
It's a massive leap. But it set the stage for Aristotle. He looked at that medical model and thought, this explains everything.
So this leads to his qualitative theory. He maps those qualities onto matter.
He does. Fire is just the combination of hot and dry. Air is hot and moist.
Water is cold and moist. Earth is cold and dry.
And because they share these qualities, they can change into each other.
This is the part that's so hard for a modern brain to accept.
Think about boiling water. You add heat. The water, cold and moist, takes on heat and becomes air, or steam, which is hot and moist. For Aristotle, the element itself was transforming.
It's a world of transmutation, not just rearrangement.
Exactly. So that's the qualitative view. Reality is about the kind of stuff things are. But
Then comes the rival squad, the opposition.
the atomists, Leucippus, Democritus, and later the Roman poet Lucretius.
And they looked at this fluid, changing world of Aristotle and just said, no, that's not right.
They argued there has to be a fixed limit to the breaking. If you keep cutting something, eventually you hit something that fights back.
Atomos.
Greek for uncuttable.
So, unlike Aristotle's shifting elements, the atomists believed in what the essay calls solid singleness.
Atoms don't change. They are hard, eternal, indestructible. All the change we see in the world is just these little hard balls rearranging themselves.
It's a Lego universe. The bricks never change, only the castle does.
But this creates a massive logical problem. If you have these hard little seeds moving around, what are they moving in?
You've hit on the controversy that stalled physics for centuries, the void.
The empty space.
Because if the atoms are being, then the space between them has to be non-being. It's nothing. And how can nothing exist?
That was the argument. Aristotle, later Descartes, they all said the atomists were talking nonsense. You can't have a box full of nothing.
It does break your brain a little. For the atomists, that nothing had to be real. For the universe to work, you needed two things, the atoms and the void.
Without the empty space, the puzzle pieces are locked tight. Nothing can move.
So we have a stalemate. The Aristotelians have a world that makes sense to our senses, hot, cold, changing. The atomists have a world that makes sense to logic, hard math, unbreakable parts.
And they were arguing past each other for 2,000 years.
We are going to see how that stalemate finally broke. But first, a brief pause for the mind.
Indeed.
Before we get to the modern twist, a quick word about Mindful Moments, our YouTube channel offering AI book analysis, summaries, and critiques inspiring reflection and rational thought.
If you like digging for the bedrock of ideas, that is the place to be.
Absolutely. Okay, let's leave ancient Greece and jump forward to the 1700s. Enter Antoine Lavoisier.
The father of modern chemistry. And he completely changes the game.
How so?
He looked at the four elements, earth, air, fire, water, and basically said, this is just a hypothesis. I want proof. He introduced what we call an operational definition.
He basically said, I don't care about the metaphysics. I care about the test results.
Right. If I boil it, burn it, and dissolve it, and it's still just gold, then for all practical purposes, it's an element.
That word practical is doing a lot of work there.
It's epistemological humility. He's saying, look, oxygen might be an element, or maybe we just haven't found a hammer big enough to crack it yet.
So he turned the definition of element from a philosophical dogma into a temporary status.
A title you hold until science builds a big enough hammer to break you, which is exactly what happened to the atom itself.
But before we get there, we have to talk about the clash of the titans in the 17th century. Isaac Newton versus René Descartes.
This is where the battle lines were drawn for the modern era. Newton was firmly on Team Atom.
He believed God created matter as solid, massy, hard, impenetrable particles.
A divine machine made of billiard balls. But Descartes hated the idea. He argued that matter is just extension.
Meaning if something takes up space, it's matter.
And you can always divide space in your mind. If I have a tiny box, I can imagine half that box.
So an indivisible atom was a logical contradiction to him.
Yes, and he also denied the void. He believed the world was a plenum, completely full of matter. No empty space anywhere.
So we're stuck again. Hard particles versus continuous stuff. But then Michael Faraday comes along in the 19th century to mess everything up.
Faraday's where things get weird and recognizably modern.
Why? What did he do?
He looked at electrical forces and realized the hard ball theory didn't make any sense. How do magnets grab each other from a distance if they're just hard shells?
Good question.
He proposed that atoms are not solid things at all. They are centers of forces.
Centers of forces. That sounds less like a rock and more like a ghost.
It's profound. He said atoms are mutually penetrable.
Wait, they can walk through each other?
Imagine two waves in the ocean. They don't bounce off like billiard balls. They pass through each other. That's how Faraday saw matter. Solidness is an illusion created by the interplay of forces.
That's a total shift. We've gone from hard and uncuttable to swarms of power.
And this brings us to the philosophical core of the entire essay. Adler synthesizes this into a battle between quantity and quality.
Break that down for us.
The element theory, Aristotle's view, focuses on quality. Things are fundamentally different kinds of stuff. Water is different from fire.
Okay.
The atomist view focuses on quantity. Everything is the same stuff. Atoms just arranged in different shapes, sizes, and weights.
So is a diamond hard because it's made of hard stuff? Or is it hard because its atoms are arranged in a specific geometric pattern?
Exactly. The atomist says it's just the arrangement. The quality is an illusion created by the quantity.
But here's the question I've been dying to ask. We have particle accelerators, we've smashed atoms, protons, electrons, quarks. Hasn't science solved this? Don't we know the atomists were right?
This is Adler's most profound point, and the answer is no.
Wait, really? How can you say that?
Adler argues that experimental science cannot solve the ultimate question.
Why not?
Because science can only prove divisibility, we can split the atom into electrons. Great. Now, is the electron the bottom? Or is it made of strings? Science can only ever say we haven't split it yet. It can never prove it cannot be split.
I see. You can't prove a negative. You can only prove that your current knife isn't sharp enough.
Precisely. The question of whether matter is infinitely divisible or stops at a hard limit is, in the end, a philosophical choice, not a scientific fact.
That is wild. It means we're still sitting at the same table as Democritus and Aristotle.
And there's another challenge to the atomists: sensation. If atoms are just colorless, odorless, silent little shapes, how do I see red? How do I feel heat?
The hard problem. If reality is just quantity, math, and motion, where does the quality of our experience come from?
Exactly. Critics argue atomism struggles to explain the very sensations we use to do science in the first place.
That is a headache. So what does this all mean for us today?
Well, Adler points out this element thinking applies everywhere. Look at genetics.
DNA base pairs.
They're the elements of life. But to a chemist, that DNA is a molecule. To a biologist, the base pair is the bottom floor. If you break it further, you lose the genetic information.
Economics has price factors. Linguistics has phones. We're always looking for the simple parts.
And we're always defining the domain we're looking at.
So who won? Team element or team atom?
Adler suggests we actually use both. In modern science, we use atomic theory for quantitative analysis, chemistry, math, calculating weights.
But we use the elemental theory for qualitative classification. We classify things by their properties, metal, gases, just like Aristotle.
Beautifully said. We calculate with atoms, but we experience elements. We need the math of the particle to build the bridge, but we need the reality of the solid steel to drive across it.
This has been such a journey. From the four humors to force fields. If there's one final provocative thought you want to leave us with, what is it?
I would say this. Since we can never experimentally prove that matter stops at a hard limit or not, the question of what reality is remains wide open. When you touch a table, are you touching a swarm of force fields, a lattice of hard balls, or a solid substance? Science tells you how it behaves, but philosophy asks what it is. And that answer is still up to you.
A swarm of force fields. I think I'm going with that one today. Makes walking through a door feel much more adventurous.
It certainly does.
Thank you for guiding us through this dense but fascinating essay.
My pleasure.
And for you listening, we want to know what you think. Are you Team Atom or Team Element? Click the link on screen for more on this and other essay subjects. Subscribe, share, purchase via link, and think rationally.
Indeed.
See the many genre-based book podcasts at Mindful Moments. Nourish your mind on the go.